Hi, welcome to ChemTube channel. I'm Jaegu Wong. In this video, we are going to revise the topic. After that, we do some questions in paper 1, paper 2 structure and essay. Do subscribe our channel, like and share this video with friends. Okay, today we are looking at the development of the periodic table of elements. So, advantage of classifying the elements in the periodic table. So, what is meant by periodic table? It is an arrangement of elements in the order of increasing of proton number. So, this is a periodic table. So, what is the advantages? So, periodic table enables the chemist to study, understand and remember the chemical and physical properties of all the elements and compounds in the orderly manner. Okay, besides that, the properties of the elements and their compounds to be predicted based on the position of the elements in the periodic table. And then periodic table also enables the relationship between the animals from different groups to be known. So these are the three advantages of arranging the elements in the periodic table. So there are some scientists in the contribution to the development of the periodic table. So the first one is Antoine Lavoisier. Okay, he is the first one. So he discovered that substances are classified into 4 groups with similar chemical properties. Next would be Dobereiner. Dobereiner discovered that substances were arranged into groups of 3 elements with similar chemical properties. Then groups of elements with the similar chemical properties are called threads. Okay. Then thread system was confined to some elements only. After that is John Newlands. So he discovered that elements were arranged in the ascending of the atomic mass. So law of octave, because the similar chemical properties were repeated every 8 elements. So this system is inaccurate because there are some elements with wrong mass of the number. Okay, so he discovered law of octave. Lothar Meyer plotted the graph for the atomic volume against the atomic mass. So he found that the elements with the similar chemical properties were positioned at the equivalent place along the curve. So next is the Mendeleev. So Mendeleev discovered that elements were arranged in the ascending order of increasing of the atomic mass. So elements with the similar chemical properties were placed in the same group. So empty space were allocated for elements yet to be discovered. So he contributed to the formation of the modern periodic table. So last one is Henry Moseley. He classified the elements based on the concept of proton number and arranged elements in the order of increasing of the proton number. So he is the contributor to the formation of the modern periodic table. Now we look at the arrangement of in the periodic table of elements. So the first one, write the electron arrangement for the atoms of each element in the periodic table below. So here is given to you. So X is a symbol, A is the nuclear number, then Z is the proton number. So this is a group and this is a period. Okay, so there are 18 groups altogether. Then there are 4 periods in these diagrams. So first one, okay, we can see here. So what is the arrangement, electron arrangement for the hydrogen? Okay, so 1 proton, so 1. Okay, for helium is 2. Then lithium is 2, 1. Beryllium is 2, 2. Okay, for boron is 2, 3, then 2, 4, 2, 5, 2, 6, 2, 7, 2, 7, 2, 8. Okay, then for sodium is 2, 8, 1, 2, 8, 2, 2, 8, 3, 8, 4, okay, so in the SPM level, okay, the electron arrangement that you need to know is until calcium 20 proton number, so it's 2882. So what is the basic principle of arranging the elements in the periodic table? So based on what we have done just now, the elements in the periodic table is arranged horizontally in the increasing number of proton, right? Okay, proton number. So there are two components in the periodic table. So first one is a group. Group is the vertical line. Okay, so this is a group. Group 1 until group 18. Then another one is a period. There are period 1, period 2, period 3, period 4. Actually, there are 7 periods. 7 periods. Okay, so first one we look into what is the meaning of group. Okay, so there are the vertical group. Okay, vertical column of the elements in the periodic table that arrange according to the number of valence electrons. Valence electrons in their outermost shell of the atoms is called a group. Okay, as we can see here, so you can see for the group 1, all the valence electron is 1. Okay, and then for group 13, for example, is 3 valence electrons, and so on. Okay, so how is the group number related to the number of valence electrons? So there are 18 vertical columns. So group 1, 2, and 3 until group 18. So number of valence electrons, you see, if 1 valence electron is group 1. So 2 valence electron, group 2. Then 3 is 13, 4 is 14, and so on until 18. Okay, 18, except the helium. Helium only valence electron is 2. So for more than 3, for the group 13 until group 18, for the atoms or elements with 2 to 8 valence electrons, the group number is 10 plus the number of valence electrons. So meaning that let's say 3 valence electrons, so plus 3, so be plus 10 will be 13. Okay, 4 plus 10 will be 14, and so on. Okay, so certain groups they have the special name. So what are the names for these certain groups? So group 1 is called alkali metal. So group 2 is alkali earth metal. 3 to 12 is called transition elements or transition metals. Group 17 is halogens, and group 18 is noble gases. Okay, so how is the group number related to the type of substance? Okay, so group 1, 2, and 13 is metals. Group 3 to 12 is the metals. They are transition elements. Then group 14 until group 18 is non-metal. So this is very important. So you have to remember that. Next one is a period. So what is period? So period is the horizontal row of elements. Okay, so horizontal row of elements in the periodic table consists of the same number of shells. occupied with electrons in an atom. Okay, so it is called period. So how is the period number related to the number of shells? So if one shell, period 1, two shells, period 2, and then until period number 7. So meaning that let's classify it. Period 1, it has two elements only. Yeah? Okay. Period 2, it has 3 and period 2 and 3, it has 8 elements only. Then period 4 and 5, 18 elements. Period 6, 32. Then period 7, 23 elements. So short periods is an period 3 will be studied in details with respect to the physical and chemical properties. So this one we will learn in this chapter later. Okay, now I do some exercises. Okay, complete the table below. Okay, helium proton number is 1, so electron arrangement is 1. So valence electrons also 1. So it is in group 1 because valence electron is 1. Shells also 1, so it is in a period 1. Okay. For helium, electron arrangement is 2. So valence electron is 2. So it is in group, this is special. Helium is under group 18. Number of electron shells will be 1. So it is in period 1. Okay. Then for lithium, 3 electrons, so 2, 1. So valence electron is 1. So it is in group 1. Shells, number of shells is 2. So it is in period 2. Okay. Next one, beryllium, 4 protons. So electron arrangement is 2, 2. So valence electron is 2. So it is in group 2. Then the shells also 2 shells, so it is in period 2. Okay, for boron, okay, 5, so it will be 2, 3. Okay, then valence electron is 3. So remember, if 3 and above, the group will be plus 10, so it will be 13. Shells will be 2, so period 2. Okay, carbon is 2, 4. So valence electron is 4. So 4 plus 10 will be 14. So shells will be 2, period 2. Again, nitrogen is 7 protons, so it's 2, 5. So 5 valence electron, so it's 15. So 2, period 2. Okay, oxygen 8, so it'll be 2, 6. So 6 valence electrons, so plus 10, so it'll be 16. So 2 shells, so 2, period 2. Okay, fluorine is 2, 7, so 7, so 17. 2 shells, so period 2. Okay, neon is 10, so it'll be 2, 8. So 8 valence electrons, so plus 10, so it's 18. Noble gases, 2 and 2. Okay, sodium is 2, 8, 1. Okay, so now it will be 3 shells. Okay, so 1 valence electron, so group 1. So 3 shells, so period 3. Okay. Then magnesium is 2, 8, 2. Okay, so 2 valence electrons, so it is group 2. So 3 shells, period 3. Okay, aluminum is 2, 8, 3. Okay, so it is 3 valence electrons, so plus 10, so it's 13. 3 shells, period 3. Okay. Next, we look at how the chemical symbol which represent XYZ is given to you. Okay, this one more to essay question. Okay, so now explain how the how to determine the position of the element X. So we look at this one first in the periodic table. So here for elements X, we will look into the proton number. Okay, so the proton number is 11. Then the number of proton in the atom X is 11. So the number of electrons also 11. Okay, 11. So the electron arrangement for the X is atom of X 2, 8, 1, right? Okay, so meaning that elements X is located in group 1 because the atom X has 1 valence electrons. Okay, 1 valence electron. So elements X is in period 3 because the atom X has 3 shells. 3 shells occupied with electrons. Okay, so this is how you explain the position in the elements in the essay part. Essay part. Okay, B. State the position of the elements Y in the periodic table. Okay, so next is explain how to determine the position of the periodic table for element Y. Okay, so meaning that how are we going to explain? Okay, so where is the position? First, we look into the proton number is 6 protons. So electron arrangement is 2, 4. So we know that. So you can write down for first one, elements Y located in group 14 and period 2. Okay, so this is how for number 1. Okay, now you have to explain why it is in group 14 and it is in period 2. Okay, so first we can mention proton number of element Y, atom of Y lah. Okay, is 6. Okay, yeah. So meaning that the number of protons, meaning that number proton in atom Y is 6. Okay, so meaning that next the electron arrangement of atom Y is 2, 4. Okay, so 2, 4. So element Y located in group 14 because it has 4 valence electrons. Okay, then element Y located in period 2 because it has 2 shells. Okay, 2 shells occupied with electrons. Okay, so this is how you explain or answer the question in the essay part. Okay, Now, which of the above elements shows the similar chemical properties? Explain your answer. So, same chemical properties, we have to see same group or same valence electrons. So here we can see, we can list out the electron arrangement. For Z to be 2881. So it's 24. So it's 281. So meaning that X and Z, they are in the same group, X and Z, because same valence electrons. Okay, so we can answer the question already. So first we can mention is element X and element Z. Okay, so why? Because you can mention electron arrangement of element X is 281 and element Z is 2881. Okay, so atom X and Z, they have same number of valence electrons. Okay, so this is the basic concept of how do we arrange the elements in the periodic table. Okay, now we look at some paper 1 questions in this subtopic. Okay, so number 1, who proposed the law of octave? So law of octave is proposed by John Newlands. So how are the elements arranged in a periodic table of elements? So based on their physical properties, no. Increasing nucleon number, no. Increasing number of neutrons, no. Increasing of proton number, yes. Number 3, which are the elements recently reintroduced in the periodic table? So okay, this one is out of the scope, but never mind, just for your extra information. So the answer is, okay, let me see, what is the okay, yeah, the first one, yes, moscovium and nihonium. Okay, these two are not recently added, so it's 1 and 2, so it's A. Okay, it's A. So question number 4, diagram shows the position of elements P, Q, R and S in the periodic table. So P, Q, R and S. Okay, so what is the characteristics of P, Q, R and S? So whether it is, okay, let's check. Okay, P is group 1. Group 1 is a metal. Okay, P, metal. So B out. Okay, noble gases also out. Noble gases is for group 18. So S is noble gases. So S is noble gases. So this one is correct. Okay, the others all are wrong. Okay, now we check others. Q is transition elements. Okay, R is group 17, is a non-metal, is a halogen. Okay, good. So C is the answer. Okay, number 5. Okay, PQR are in the same period. Same period meaning that same shells, electron shells occupied with electrons. So P is a non-metal, Q is a metal, then R is a semi-metal. Okay, non-metal, semi-metal, okay, and non-metal. So meaning that which of the following correct sequence of the elements according to the increasing of proton number? So in the periodic table, left side would be the metal. So meaning that Q is the metal. So meaning that Q would be on the leftmost left lah. For P is a non-metal. Okay, P non-metal. So meaning that non-metal will be on the right hand side. And then the R is a semi-metal. Okay, R is a semi-metal. Okay, so P is a non-metal. So P is on the right hand side. R is a semi-metal, will be in the middle. Okay, so be Q, R, and P. Q, R, P. So B will be the answer. Okay, 5B. Okay, next, arrangement of periodic table in the okay, number 6. What is a factor determines position of group? Okay, group, so group is number of, okay, not the protons, not the neutrons, okay, number of electrons in the outermost shell. Okay, so this is the answer, or we call it valence electrons. Not the number of electrons in the atoms. Not very accurate. So C will be the answer. Okay, 7. Table shows the proton number for 4 elements in the periodic table. Okay, TUVW. Okay, proton number 3, 6, 11, and 17. So which pair in the same group of the periodic table? So if same group, we have to go to find the same valence electrons. Okay, so meaning that we have to write the electron arrangements first. So T protons 3, so it will be 2, 1. U is 2, 6, so it will be 2, 4. V is 2, 11, so 2, 8, 1. Then W is 17, so 2, 8, 7. So meaning that, okay, 1 valent electrons, so it will be T and V. T and V. T and V. Okay, so C is the answer. Okay, question number 8. Diagram shows the standard representation for the atoms of element Z. So 5 protons, so 11 neutrons. So which group and period? So we have to write the electron arrangement. Is 2, 3. Okay, 2, 3. So meaning that it is in the group 13, period 2. Okay, yeah. Question number 9. Table 2 shows the proton number of G, J, L, and N, M. Okay, so which statement is true? Okay, so first we look into the proton number given. So 11 protons, so is 2, 8, 1. So it's 2, 8, 2, 2, 8, 8, and 2, 8, 8, 1. Okay. So we have G and M are in the different groups in the periodic table. So G is 281 and M is 2881. So they have same valence electrons, so same group, should be same group. So A is wrong. Okay, next, G reacts with L to form the ionic compound. So ionic compound is the reaction between metal with non-metal. So this one we'll discuss in details under chapter 5, but now we just use this information. Okay, metal, non-metal, G and L. Okay, G is metal, L is non-metal. Okay, but L is non-metal is correct, but L is noble gases. Noble gases 8 valence electrons. Okay, valence electrons, 8 valence electrons is the noble gases. Okay, it's very stable. So very stable means it won't react with other elements. So meaning that this B also wrong. Solid J conduct electricity. So conduct electricity in the solid state meaning that it must be a metal. So J is a metal or not? Yes. Okay, 282 is alkali of metal. So C should be correct. Okay, M is the diatomic molecule. M is 2881. So 1 valence electron is the metal. So metal, so it's not a molecule. So it's not a diatomic. So it should be a metal. So the answer is C. Okay, number 10. Diagram shows the electron arrangement for X2 positive ions. Okay, which of the position of the elements in the periodic table? Okay, so here we have to know that for the ions, electron arrangement for the ions is 2, 8, but for the atoms will be, so X atom, it should be, okay, so X ions, okay, S2 plus, meaning that it lost 2 electrons already, so it's 2, 8, okay. So meaning that initially atom should be 2, 8, 2. Okay. Then it lost 2 electrons. Then it forms 2 plus because extra 2 protons. So X atom will be 2, 8, 2. So meaning that it is in group 2. Okay, period 3. Okay, group 2 and period 3. Group 2. Okay, so these two are wrong. Period 3, so period 1, period 2, period 3. So B is the answer. Okay. No, sorry. Okay, question number 10. Okay, let's see. Diagram shows the electron arrangement for the X2 plus ions. Okay, so which of the position of the elements X in the periodic table? So we look at this one. So for the X2 plus ions, okay, let's see what is the electron arrangement. Is 2, 8, 8. Okay, should be another 2, 2, 8, 8. Okay, 2, 8, 8. Okay, so if it has 2 plus, meaning that in the X atom, it should be 2, 8, 8, 2. So by losing 2 electrons, valence electrons, it becomes the octet electron arrangement. Then it forms a 2 plus. So meaning that here we know that it is in group 2, then period 4. Okay, because 4 shells occupied with electrons. So where is the position? Where is the position of the element X? So group 2. Okay, group 2, not the group 18. Then period 4. So period 1, 2, 3, 4. So C should be the answer. Okay, the following statement refers to the contribution of a scientist in the development of the periodic table. Plotted a graph of atomic volume against the atomic mass of the elements. successful in showing that the properties of the elements formed in a periodic pattern with their atomic mass. So who is this scientist? Huh? Okay, so this scientist is Lothar Meyer. So diagram 3 shows electron arrangement of an atoms of Y. So it's atom. So Y is not the actual symbol of the element. So which for the following is the position of the elements Y in the periodic table? So let's write out the electron arrangement for this atom. So it's 2, 8, 2. So this is under group 2, and then it is period 3 because 3 shells occupied with electrons, so it's boy. Next, the following information is about atom Q and atom P. So Q is located in the period 2. Then electron arrangement for P is 281. So element Q is located above element P. Above element P in the same group of the periodic table. So which diagram shows the electron arrangement of atom Q? So meanings that atom Q will be in the period 2, because P is 281, this will be period 3. Then Q above period element P, so it will be period 2. So meanings that the answer should be C, 2, 1. Question number 4. Table shows the proton number of the elements W, X, Y, and Z. So proton number, let's. So which arrangement shows the atomic size of in the ascending order? So this one is more to the size. Now we write out the electron arrangement. This one is 2, 1, 2, 4, 2, 8, 1, then 2, 8, 2. So let's compare the number of electron shells. This one 3 shells, meaning that they have the bigger atomic size compared to 2 shells. 2 shells. So among the Y and X across the period, the size will be getting smaller. So getting smaller. So meaning that the biggest size will be Y, biggest. Followed by Z. Then for the Y and X, same period. So W will be bigger size. X will be the smallest size. But here the question mentioned is atomic size in the ascending order. Ascending order meanings that must be from the smallest to the biggest. Smallest, so it will be X, followed by W, then Z, then Y. So this one should be the answer. X, W, Z, Y. Let's see. X, W, Z, Y should be C. Next. In which of the following is the correct change in the properties of elements across the period in the periodic table? So what is the correct one? So atomic radius increases, should be decreases. The relative atomic mass decreases, this should be increases. The number of protons of each atoms increase. Yes, this one is correct. The number of valence electrons in each atom decreases, should be increases. So C is the answer. Next, what is the meaning of electron negativity? So electron negativity is the ability to gain the electrons. gain the electrons to form negative ions. Okay, so ability of ions to lose electrons, so this one is electropositivity. The ability of the ions to gain electrons, okay, not the ions, for the atoms. Ability for the atoms to lose electrons, so for the atom to gain the electrons, so D will be the answer. Okay, for structure questions, diagram 3 shows a part of the periodic table of elements. So it shows you the period 3, sodium, magnesium until the argon. Okay, so based on the diagram 3, name one element which is a metal. So a metal here should be group 1, so sodium, magnesium group 2, and then aluminium group 13. So these 3 are the metals, metals. So you can name any one of it. So since here mentioned is a name, so you have to write the full name. So it is sodium, or magnesium, or aluminium. You can pick any one of these. So number 2, which of the group and period is the metal you mentioned in 3A1? Okay, let's say we focus to sodium. So sodium is in the group 1 and period 3. Okay, yeah. So name the elements that exist as a monoatomic gas. Okay, monoatomic gas meaning that it is exists in the single atom, one atom, and then it is very stable already, and reactive. So here noble refer to the noble gases. Okay, so noble gases here will be under group 18. So here will be argon. Okay, so it's argon. Then explain why this gas is monoatomic. So monoatomic here because argon has achieved stable octet electron arrangement. Okay, which is 288. So it does not donate, receive, or share electrons with other elements. Okay, so this is the standard answer. C. Sodium react with oxygen to form the sodium oxide. This is under ionic compound, which will be discussed in chapter 5. Okay, never mind, we discuss first. So okay, write the balanced chemical equations for the reaction. So sodium is the metal, react with the oxygen. So oxygen is O2, so it forms the sodium oxide. Okay, sodium oxide. So we have to balance the chemical equation. So oxygen. Okay, so oxygen got 2, here only 1, so we times 2 here. So after times 2, oxygen is balanced, but the sodium is not balanced. 2 times 2 is 4. So we have to times 4 here. Okay, so here, by this way, we can write the balanced chemical equation. Then sodium oxide here, from here, okay, react with water, produce a solution. Okay, so in what is the pH value? So it's a alkaline. So alkaline will be pH 11. Okay, so sodium oxide actually react with water, it forms a sodium hydroxide actually. Okay, yeah, which is the alkaline. Then we have to balance the chemical equation. Let's try. Two. Okay, this one times 2. So the sodium 2, oxygen 1, 2. Okay, 2, hydrogen 2. Okay, so it's balanced. So sodium hydroxide is alkaline. Okay, state which is more electronegative, sodium or chlorine. Okay, explain the answer. So the electronegative means its ability to gain electrons to form the negative ions. So compare it, sodium and chlorine. So sodium is 281, this one is 287. So 7 valence electron is easier to gain 1 electrons to achieve octet electron arrangement. For sodium, we easier to lose 1 electrons. Okay, so your answer should be chlorine. Okay, chlorine. Okay, why? Because it has higher tendency to receive electrons to achieve stable octet electron arrangement. Okay, next question. Okay, diagram shows the part of the periodic table almost the same. Sodium, magnesium, oxygen, chlorine, and bromine. Okay, so what is the basic principle used to arranging of the elements in the periodic table? So in the increasing or ascending of proton number of elements. Okay, step 2 elements are placed in the same period. Same period means they are in the same period here. So it should be sodium, magnesium, and chlorine here. So you can put any 2. Okay, so you can put sodium or magnesium or chlorine. Okay. Alright, the electron arrangement for chlorine atom. So atom, so it's 2, 8, 7. Okay. So molecular size of chlorine is smaller than the molecular size of the bromine. Okay. This will be discussed in details under halogen. Okay, so explain why the melting and boiling point of the bromine is higher than chlorine. Okay, so molecular size. Okay, why? Okay, so when we talk about the melting and boiling point, we talk about the van der Waals force of attraction between the molecules. Okay, so you can mention the van der Waals force between the molecules increases when the molecular size increases. Okay, so meaning that this bromine has a higher melting and boiling point compared to chlorine. Okay, so more energy, more heat energy is needed to overcome the stronger force. This force is the Van der Waals force. Okay, so 2 marks. Next, magnesium react with oxygen to form the magnesium oxide. So equation. So magnesium is a metal, react with oxygen, so it forms the magnesium oxide. So it's not balanced. So with the balance equation, so oxygen times 2, so magnesium also times 2, so here 2. So state the color of the magnesium oxide. So magnesium oxide is a white color. Okay. Table shows the information on the metal X and metal Y. So metal X and Y, okay, not mentioned. So X react with chlorine to form the white solid XCl. Okay. Then react with Y react with chlorine to form the green solid and brown solid, YCl2 and YCl3. Okay, so meaning that this one, it has the 2 oxidation number. Okay, this one only 1 oxidation, so it will be X plus. So based on the table 3, identify the transition elements and give a reason for your answer. So transition elements, it has more than 1 oxidation number, so it should be metal Y. Okay, so it has more than 1 oxidation number. Okay, or it has different oxidation number, which is Y2 plus and Y3 plus. Okay, next diagram shows the part of periodic table again. Okay, M, Q, R, T, U, V, and W. Okay, so based on the diagram, so which elements is the noble gases? So noble gases is group 18. So it will be M. So which elements exists as diatomic molecule? So diatomic molecule, so it will be group 17, so it will be V. So which elements it forms amphoteric? Amphoteric later on we will discuss in details under another subtopic. Okay, so amphoteric here refer to the, it has acidic and alkaline properties. Okay, so here in the SPM level, okay, just remember it's referred to aluminium oxide. Aluminium oxide is amphoteric. So aluminium oxide is U. Okay, U. So element Q, R, and W are placed in the same group. So why are these elements placed in the same group? Okay, so same group because they have same proton, same valence electron. Okay, arrange them in the ascending order on the reactivity towards the oxygen. So towards the oxygen, so when going down the group 1, the reactivity are increased. Increase meaning that getting more and more reactive. So meaning that ascending order. So we Q, R, and W. Okay, Q, R, and W. So write a balanced chemical equation for the Q react with oxygen. So Q react with oxygen. Okay, it forms a Q oxide. Q is a group 1, so it forms a Q2O. Okay, we need to balance the chemical equation. So this times 2, okay, this one times 4. So write the electron arrangement for the atom T. So atom T is here. So group 2 and then period 3. So group 2 period 3 meaning that the first shell is complete already. So 8, then 2, 2, 8, 2. Okay, next in 2016, the table shows the information of elements in the periodic table. This is under period 3. So which period are the elements placed? So you see all are 3 electron shells, so they are in period 3. Okay, so state the elements that exist as diatomic molecules. So diatomic molecules refer to halogen. So halogen here, diatomic. So here is the chlorine. Okay, so it's Cl. State the elements that can form the amphoteric. Okay, just now I mentioned already, amphoteric refer to the aluminium oxide. So it's aluminium, so it's Al. Okay, next. So which elements is a semi-metal? So in semi-metals, actually here it will be silicon. Silicon is a semi-metal, half metal, half non-metal. Okay, referring to the change in the atomic radius, explain why the electron negativity increases across the period from left to right. So the electron negativity actually refers to the ability to gain the electrons to form the negative ions. So here we have to mention about the proton number. Increases. So when the proton number increases, it will increase the positive charge of the nucleus. And decrease in atomic size. So as a result, the strength of the nucleus to attract the electron will increase. Okay, so 2 marks. Question F is another subtopic, so we skip first. Okay, next we look into 2018, question number 2. So let's see. Diagram shows the standard representation of the atoms of X, Y, Z in the letter used are not the actual symbol of the experiment. So let's see that these are the proton number. Okay. So let's write out the electron arrangement. So this one is 2, 8, 1, meaning that this is group 1. This one is 2, 6, group 16. This one is 2, 8, 8, 1. Okay, meaning the X and Z are from the same group because they have the same valence electrons 1. Okay, now let's see the question. What is the proton number of atom X? So atom X, let's see. Atom X, so what is the proton number? So it's 11. Okay. Next, what is the elements? Which elements is an alkaline metal? So alkaline metals is for group 1. So here your answer should be X or Z, X or Z, because they have one valence electrons. Okay. Then which chemical? Write a chemical equation for the reaction when react with water. Okay, let's say you can choose X or Z. They are the same. So X react with water. So it produce X hydroxide with the hydrogen gas. So it's not balanced. We have to balance the equation first. So meaning that this one X needs to times 2 first. So after it times 2, H becomes 4. So meaning that this here we have to times 2. X also needs to times 2. So Z also the same. So you can replace the X with the Z. So 2 marks for this question. Okay. Now, which elements has the same chemical properties? So, meaning that this one will write the X and Z. Why? Because they have same chemical properties, because they have same valence electrons. Okay. Then same group, then they have same chemical properties.